so many times you hear, someone talking about science, and they say, well, here's the things we can prove. Here's the science. But if you go off and stray off into meaning, well, then you're talking about philosophy, as if there's science
Yes.
and then there's philosophy.
Exactly.
Philosophy is what you do when you cannot explain something. You just think about it. But it's talked about as if it's kind of a lesser process of thinking. And science is philosophy.
Yes. Yes.
It's all connected.
3, 2, 1. Welcome to Love Machine.
Welcome to another episode of Nerding Out. Cesar and I are back from our break, and we are jumping into a new series. But before we get into that, I want to remind you that you can go over to thatnerdycatholic.com and sign up for our email list to get the latest updates of what's going on in the nerdy Catholic verse. And we promise not to spam you, just a couple emails a month with our latest updates. If you want to support us, you can go over to thatnerdycatholic.com/merch and buy one of our t-shirts, one of our mugs, and we have some of the Nerdy Catholic tees designs over there. You can also now head over to thatnerdycatholic.com/support to support us that way. You can support us monthly, and there are special perks at different support levels. And we would just greatly appreciate any financial support you can give so that we can best use our time and our resources to bring more content and to continue to bring these conversations about truth and science and how our faith fits into it. So let's jump into it. Today we're starting, as I said, we're starting a new series, and we're starting a series on physics.
Yes.
And I'm doing it as ever with my esteemed co-nerd Cesar.
Yep. So glad to be here again. Thank you very much.
It's good to be back.
We are starting our series on physics, on going, what's physics, But we are going to start boarding that question with the, what is natural philosophy? That's what has to be philosophy with physics? That's a very tricky question.
Yeah.
But I would like to read, I grew up in, when I did my studies in Lima, Peru, there was this, book like this thick that is what it was called, Physics by Survey, very classic book. So, and but in the introduction page, when you can find Survey defines physics as the most fundamental physical science concerned with the fundamental principles of the universe and the foundation of other science like astronomy, biology, chemistry, and geology. He also stated that the beauty of physics lies in the simplicity of the fundamental principle and in the manner in which a small number of concepts and models can after expand our view of the world around us. The key word here is simplicity, and fundamental principles. Those key words are the things that defines the best physics.
Yeah, it brings to mind the principle of Occam's razor, which I hope we get into at some point. But yeah, all things being equal, the simplest definition is probably the right one.
Yeah.
And that there's, I like that idea of the simplicity of trying to find the fundamentals of nature, of the world around us.
Yep. And that's has been always the case when we see the foundations of the laws of physics. F equals mass to acceleration. It was the force. That's 3 letters there. Yeah. A simple equation, and we solve most of the problem of physics in college were related to that.
Yeah, it's amazing when you look at the formulas that are used in physics that that for so many things that we can observe, yeah, they're just very simple.
Mhm.
There's a lot behind them, and there's a lot that brought us to discover them, but in and of themselves, they're very kind of basic.
Yes. And I would like to start this conversation also with with Isaac Newton. No, Isaac Newton was one of the greatest physicists that have ever lived in the earth. Not because of yes, he was a very genius guy, but also the legacy that he left. One of the books that he wrote, their book, which is it's called the Principia, but the complete title is Philosophy Naturalis. I'm sorry, I'm trying to read Latin here. Philosophy Naturalis Principia Mathematica, which means mathematical principles of natural philosophy. No, and take a look that he didn't say mathematical principles of physics. He
Or
said,
of the physical sciences.
yes, he said mathematical principle of natural philosophy. No, so I want to highlight why did he say natural philosophy. No, and this is something very powerful because sometimes I think we forgot that philosophy is not like a ramble things that a Greek person thought 25 centuries ago or something like that. Philosophy is the love of wisdom as defined in the Greek. No? And we have to incorporate that because it doesn't say only the love of natural wisdom, it says the love of wisdom. So wisdom is something that is big, great, and by the way, it's mentioned in the Bible that it's a good thing. No?
Yes. Yeah. Yeah. There's even a book named
Yes.
after it.
There you go. So the meaning of his Newton's famous book is trying to pursue what are the mathematical principles that you can see in the nature. That's basically it. And I love it because for two reasons. No, the first reason is that if you have ever read the book, of course, there's a version in English of that book. You start, with the definition of this is mass, this is how we define momentum. So he start like the Greek did with the Mathematica. If you haven't seen that, please see our series on math. But it is the same structure of the book. No? You start with the building blocks, with the definitions, and then he start building the physics, which is the foundation of the modern physics that we have right now. No, so
And as we've said, and because we talked about Newton in our series on math, that we have so many terms that we have now even have Newton in their name.
yes,
We have the measurement
yes,
of energy, the Newton.
Mhm.
You have Newtonian physics, Newtonian geometry.
Yeah.
There's so many things that we do even now are based on the work that Newton did.
That's correct. We already stated that physics is natural philosophy, and we already stated that philosophy is thinking. No, so when we start this process, no, usually when we were kids, we start saying, "Hey, at the age of 4, my little kid is in that age right now. Why is this happening?" No? Okay, so why are we going outside right now? Well, because it's better to 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 drive during nighttime than during nighttime. It's harder to see. So why is the sun only during the day? Oh, come on, and you start seeing the why on everything, no? So that's I would say that's kind of a human nature here, no? We want to see, we want to perceive the world around us. We want to ask the why.
Well, we want to understand.
Yes.
There's a drive in human nature to want to understand the world around us. And as you said, that starts at such a young age to look around. And um, I remember when I learned this about the development of our brain, that the reason why we don't remember anything before 3 years old or so is that our brain is actually working to build the structure within it to understand the connections and how everything connects to each other. And so you can actually say that we're hardwired to desire to understand the world and to desire how to understand how everything fits together. So I think that process, that period of early childhood, while as a parent can be at times very annoying,
Yeah.
is wonderful to say, well, why does this happen? Why does this happen? I want to understand all of it.
Yes, and you're right. I think every kid, you can see when they, before they start to talk, they start gazing upon one and another thing. They start shouting, expressing emotions. They don't know what the emotions are because they don't have, the apprehension of the word in their mind right at the moment. But you can see in their eyes in their interaction with the word. It's true. It's really amazing.
Yeah, and I love that connection of philosophy with science and in the idea of natural philosophy, because why do we do science? We do science to understand the world, and it's all just different thought processes. It's how do we think about the world, and as we'll discover going through this series, as science develops and as physics develops and grows, just the way it happened with math, but even more with science, because we have the tools develop and grow, and our understanding develops and grows. We have more processes, more tools to use in different scientific processes, but it's all to be able to think about how the world works. And so in that way, it all goes back to philosophy.
Yes, and talking about philosophy, we have talked about, when we're kids, we want to see the world around us. As we grow up and we understand and we interact with other people and with the world around us, more fundamental questions came to our mind. No, who are we? I mean, I'm not meaning that our name by itself, but who are we? Where we came from. What is the purpose of my life? And those are really important questions to ask. Why do I exist here? And if I have a mission to fulfill or not, what is that? Those are really fundamental questions that we ask. But as you said, it's still a human being trying to understand. But you can see as human beings mature, they start to connect with things that transcend, and they want to understand things that transcend nature, transcend that you can see, purpose in their own life, purpose on why are we here, how we came to be, what is the purpose of our existence, and those are very important questions to be answered too, but are not usually being addressed in the modern world,
And I think one of the fundamental questions that's taken for granted, and I think this is something that we will come back to a lot in this series. Why does the world make sense?
Yeah.
Why is there order instead of chaos? You can imagine, jumping ahead, looking at the early process of trying to explain the world. Of, well, this God did it or that God did it.
Yes.
And in that way, in that world, it's very chaotic, because everything that happens is on the whim of one of the gods.
That's so true, and it's funny because when you see the our ancestors will think, there's there's no rain. There must be a god of rain, and he must be angry. No, that's kind of the explanation, because they saw themselves. They saw people that are angry, and when people are angry, take revenge. So they assume that character that they have into their gods. But of course, imagining them more powerful than us, no? So, in that sense, human beings created their gods in order to have the answer that they want, no? Until, and I think we can start measuring this, starting with this process. Some of the scientists said, what is this? Instead of being the gods, it's been this thing.
Right. Well, and looking at the history of science, the history of science came out of the Judeo-Christian tradition, because when you have one God that created everything, what God revealed to us in the Bible, and in the history of the Jewish religion, and then into the Christian religion, into the church, he revealed himself as a God of order, and a God that is involved, but does not make decisions on a whim.
Yes.
Like we saw when people assigned, like you said, with the rain god or the sun god, or any natural process, assigning a god to it. Say, well, if they're in a bad mood, then we're not going to get rain today. But the Judeo-Christian view of the world is a world of order, and so people start to think, well, if there's order to the world, we can understand it. So how can we understand it? Let's start looking into that. But I think even thinking about the process of assigning natural phenomenon to a certain god is, in a way, a version of science, because it's still trying to explain the world. We never just sat around saying, okay, I'm just gonna sit here and not think about anything. Not even assigning something to a god. It's still a way to explain what's going on around us.
That highlight that you made about the Judeo-Christian giving an answer on why we can make science is so important. And I can see some people in the comments will say, no, science start with Egyptians, Babylonians, doing different things. But this is the highlight here. People that start doing science, they start seeing that pattern of there is logic in what I see. I want to understand that logic. That is the most important thing. So it is not a fact that science was exclusive to Judeo-Christian. It is there for everybody that wants to see, hey, there's an order. I want to go and explore that. So it was always there for everybody. But the only religion, let's call it like that acknowledge that is the Judeo-Christian religion right now. And the other thing is, and I want to highlight this too, because whenever somebody see the war and see the order and want to start science, they do always an act of faith, saying, I am thinking that in the way that I'm going to go, there's an order, and I want to discover that. That's an implicit process that we do not think about that, no? So, for example, when Thales de Mileto, I want to start seeing the early Greeks that we have on science here, that we all learn, no? Thales de Mileto claimed that the first principle of things is water, no? His theory was supported by observation of the moisture through the world, and coincided with this theory that the air floated over the water, no? So even though that's not exactly a good explanation, but that's not an explanation attributed to God. That's an explanation from the observation.
Yeah, from what he sees. He's like, oh, I
Yes.
see the land, and I see that the land is surrounded by water.
Yes.
It's an interesting. He saw the world around him. He said, well, let's think about this. How can we explain the connection of the land and the sea?
Yes. The other one, Anaximander, for example, he noted that water could not be the fundamental stone because it cannot be the rise of the opposite, which is fire. No? And we are talking about Anaximander here centuries before Christ. And Anaximander, through observation, was able to say that the earth does not float on water, but is a circular disk floating on infinity. He didn't get the ball, he didn't get the disc, but there you go. By observation and reasoning, he came from something very similar that we have right now. No? So, and we can continue here, no? Empedocles held that there are 4 elements, no? Which everything is derived, no? Earth, water, fire, and air, no? And there was a 5th element, ether, which heavens is derived from, no? So he saw the 4 elements for the earth and the ether for whatever is outside there.
We now know is called dark matter, right?
Yeah. Or it's something that even I want to make a parenthesis here. The ether idea will say, hey, that's very ancient. No, ether, there was thinking about ether just until the time before Einstein. No, when scientists were trying to measure the ether, the ether's constant, because they assume that the light go through ether into the earth. No.
Yeah.
So don't laugh about Empedocles. He got it something that survives until almost before Einstein.
You think about our view of the world 100 years ago. We hadn't been to space.
Yes.
We're living in a world now. We're living in a time now where we have actually been in outer space.
Yes.
We have been to the moon. We have walked on the moon, and so we have traveled through what at one point in the not too distant past, where we thought, oh, there, yeah, as you said, what's out there, and so this idea that of the ether still existed because we had no experience of what was outside of our atmosphere.
Exactly. That's a very good point. And we still, and right now we are living in a time when that we have an international space station outside, something that 100 years ago men didn't.
Or
I want to go to space. Well,
yeah. And you had Jules Verne writing stories about traveling in space.
Yep.
But outside of science fiction, I think I often wonder, what if you had gone back 100 years and said, 100 years from now, there'll be people living up in space.
Oh, or like Elon Musk want to people living in Mars.
Yeah.
Colonize Mars. That's I think that's possible. It's just if human beings wants to do that instead of wasting time on wars and things like that. No, but I think it is possible.
Yeah.
So there's a couple of examples more that I want to mention here. No, Leucippus and Democritus, 2 Greek philosophers, theorized that the matter could divide in small particles. No, and that's when we get the word atoms from. No, so the Greeks were saying that there's something so small that cannot be divided. That's atom by definition, cannot be divided. And right now we know that atoms can be divided, but how long does it took for us to know that? No. And then Aristotle, one of the geniuses of of the Greeks on the ancient time, he rejected the atomic theory. He got many things good, but he rejected atomic theory, saying that air is primary wet and secondary hot. So he divided the four terrestrial elements and assigned a sense of touch. And why do I want to highlight the importance of the sense of touch to analyzing air, fire, hot and dry, earth is dry and cold, and water is cold and wet? Why do we want to highlight this? Because that's implying that senses has to do with analyzing our world, what we can see, what we can smell, what we can touch. So
we can look at what Aristotle said and thought and say, well, he was just wrong.
Yes.
But as you said, he was going by what he could observe.
Yes.
And going back, and I know we'll go back to Galileo, but the tension between what Galileo thought and taught, it was based, a lot of it was based on, well, what can we observe and what can we actually measure and show at this point?
Yes.
Looking back, we can say, well, Galileo was right. But at the time, the process was still happening and the equipment was not sensitive enough to say, this proves beyond a shadow of a doubt that what you're teaching is correct.
Yes.
There's no question about it. That time would come, but it was not at that time.
Exactly. And that is so a very good statement, because we can see also in this example from the ancient Greeks that they start to try to use their senses. They start to think and use their senses, and they start to make a hypothesis. No, so this is very important statement, because right now we are forgetting this. Science, physics start with thinking and with making an hypothesis, and have a process of trying to prove that hypothesis with whatever we have around us. No, they didn't have the scientific method yet at this point, but they try to approach to something really similar. No.
Yeah. Well, I think we were talking about before we started recording that the word that popped in my head, and I don't know if this is a phrase or word that people have used before, but I thought of this word, the proto-science. It was like a proto-scientific method. The scientific method did not happen instantaneously.
Yes.
It grew and it developed over time to say, well, how do we understand the world? How do we experiment to understand it better? How do we refine our tools to be able to get more precise measurements? And so this process of the scientific method grew over hundreds of years. And you look back, even as we said, even back to the early Greeks, all the way through time, that it was this desire to understand the world, and the methods slowly developed over time to including this Aristotle. Well, how do things feel? If I use my senses, how can I start to characterize and categorize the things around me?
Exactly. And that is a very important statement, because, as you said, those were the tools that they have. No, but there was a missing part here. No, how do I know that the process that I am following and that the result that I have actually makes sense and doesn't contradict with whatever other people that has the same experience, the same reality in front of them can have? How can we argue that? No, and this is a very important statement, because that answer through thinking was, okay, how does this really make sense and doesn't contradict with another statement? That's when logic was rising. No, so the process of thinking, the philosophy, came to its own rescue to say, how do we make sense of our process and our conclusions, and the logic was born, no? And when we try to measure, math was born, no? And the metric system, and I'm sorry, and the measurement system, not the metric system.
Long time
yeah,
after.
long. So you see that from thinking, which is kind of the root of the wisdom, the love of knowledge, you derive logic, you derive math, no? So we are starting to see a pattern here, no? So it is very important to always ask this question: does this make sense? Is this contradicting whatever other people with similar experiences have, no? Or can two different people following a process can become to a same conclusion if they are looking at the same reality? And that is important to notice, no? Because as a rational being, verifying that our process and our conclusion is true is very important, because that is a knowledge that is not just my view or my opinion, it's I am really reaching the reality if another people can go through the same process and came to the same conclusion.
Well, and two things that are very important for this development and this understanding of reality, of truth, is that we pass this truth on from generation to generation. I often think about the whole of human history as the lifetime of a person, because as you grow, you develop knowledge, and you continue to get a better understanding of the world around you, of your place in it. So as throughout history, knowledge is developed, processes are developed, but they're passed down, and then also the other thing I was thinking is that being proved wrong is just as good as being proved right.
Exactly.
Because you're understanding the world better. That's, I think, a very important part of the scientific process, is that you come up with we talked about a couple of episodes ago. You develop a hypothesis and you test it, and then you either prove or disprove your hypothesis. But having it being disproved is just as good as it being proved, because you have a better grasp on what's true.
Yes, you are building, and right now it requires. It's a good point, because sometimes it requires to be humble, to acknowledge that, well, my hypothesis is not true. If you're humble, you recognize it's not true. Yeah, no, I know that this is not the route. This must be the route, no? And you pursue another thing, but you feel the excitement, no? But if somebody is not humble, say, "Oh, I don't like this. It's not going to be. Look at me, and I can start twisting the things." No, so it's really important when you do this process to be humble enough to pursue truth, to formulate your hypothesis, and to say, "Hey, maybe this wasn't the thing. I will try another thing." That's a good thing.
Just a quick aside.
Go ahead.
I think sometime we should have on a good friend of ours, John Mark Grodi, who he has done a lot of work and thinking about the virtues. But I think it'd be really interesting to look at, you bring up humility, look at the connection between the virtues and the scientific process.
I agree. Let's do that.
I think that'd be a great conversation. I like the direction this conversation is going. I think you put in the notes for the episode today this quote from C.S. Lewis, and C.S. Lewis wrote a book called The Screwtape Letters, and the idea behind the book is that you're looking at the world of the demons, and I think it's kind of odd to think about a Christian writing a book about demons, but you have this one demon who is mentoring a younger demon, and so he's showing him, how do you tempt someone?
Yes.
And so he has this young demon has been assigned this brand new Christian, and he's like, well, how do you tempt him? How do you pull him away from the faith? So and so it's written as a series of letters written back and forth. So this one demon wrote to the younger one, it sounds as if you supposed that argument was the way to keep him out of the enemy's clutches. That might have been so if he had lived a few centuries earlier. At that time, the humans still knew pretty well when a thing was proved and when it was not. And if it was proved, they really believed it. They still connected thinking with doing and were prepared to alter their way of life as a result of a chain of reasoning. But what with the weekly press and other such weapons, we have largely altered that. Your man has been accustomed ever since he was a boy to have a dozen incompatible philosophies dancing about together inside his head. He doesn't think of doctrines as primarily true or false, but as academic or practical, outworn or contemporary, conventional or ruthless. Jargon, not argument, is your best ally in keeping him from the church. Don't waste time trying to make him think that materialism is true. Make him think it is strong or stark or courageous. That is the philosophy of the future. That is the sort of thing he cares about. It's an interesting look at the modern dilemma of making argument. And this was written back in, I think, in the 30s or 40s, and I think in some ways this is even more true today than it was then. That that looking at the few centuries earlier, that the height of the use of the scientific process,
Yes.
when that was, I guess you might say that was the in thing, the popular thing, right? But today, I would say, as I said, even more so today, why do we say something is true? Well, because it sounds good, it feels good, and so so I think in a way we're living in a time when the scientific process is seen. In one way, there are people who say, well, the science is all that matters.
Yes.
In another way, it's like, well, the way a lot of people act, the scientific method doesn't matter, right? Because there's so many things that are happening that if you step back and say, well, let's just logically look at this, it's like, well, don't use logic.
Yeah.
that doesn't feel right to me.
And that's a very good point, because modern men are so many times in front of a screen, either a phone, a TV, a tablet, a computer, and we are getting accustomed to hear things, but we are not getting accustomed or used to think about those things. Because thinking requires to step back and to process the information. But if you are only consuming information without making that pause, and I think right now in some schools, and I think you and I, that's why the reason we decide the schools the kids we have are right now, it's some schools, just even some college, I would say, just, hey, this is the information, you just grasp, but they don't teach you how to think. They don't teach you how to debate, how to analyze an idea, how to argument an idea, and or how to ask appropriate questions and question those ideas. Even the art of asking questions that go to the fundamental of the arguments of somebody else, it's really important. It's really important.
I think that this concept then, or this realization, bringing the physical sciences back to the root of natural philosophy is so important. Because, as you said, so often in schools now, it's like, here's a fact, here's a fact, here's a fact, here's something that happened in history. It's just learn the facts and be a good worker,
Yeah, exactly.
and not don't think about it too much.
Yeah.
Just learn all these things. Make sure you can pass the tests. Make sure you have enough knowledge to get a good grade and move on in life. And as we've talked, as you said before, so many times you hear, someone talking about science, and they say, well, here's the things we can prove. Here's the science. But if you go off and stray off into meaning, well, then you're talking about philosophy, as if there's science
Yes.
and then there's philosophy.
Exactly.
Philosophy is what you do when you cannot explain something. You just think about it. But it's talked about as if it's kind of a lesser process of thinking. And science is philosophy.
Yes. Yes.
It's all connected. And so my children go to a classical school, and I love it because they're learning the history, but they're also but at a certain point they start learning how to think about
Yes.
the science, the history, how to put it all together.
And that is a very important skill that we need to recover in our education system. No. So, for example, one of the exercises of our kids regarding history is in the independence of the USA. No. So they are getting together and they are trying to reason. What do we need to do in order of these new taxes that British are doing, no? And they enact that, and they try to come up with things and reason and put in the shoes of the people and came to a conclusions, no? And that's a very important way to see history. It's not just this in this year happened this, in this year happened this. It's important to think why they came to this conclusion, to put in their shoes and try to think what they saw and what they lived at that time. No.
Well, and if you are just learning facts, then you just come to a natural conclusion of, well, this is what happened, therefore this is what was supposed to happen.
Yes.
Therefore this is a good thing.
Yes.
And no matter what country you live in, no matter where you are or who you are, there are things you can see that happened that should have happened or shouldn't have happened, or and you need to think about that. And people will have different opinions about saying should or shouldn't. But you can't just take everything that has happened up to this point as a given and a good.
Yes.
You need to be able to think about the world around you. And it's not just, science is not just learning a bunch of facts, just like history is not just learning a bunch of facts. It's using your mind and thinking about it.
And that's a very good point, because there was a scientist in the past that started saying, hey, but what if this is not true? What if this is not true? What if this is not true? How do I came up on a conclusion like that, no? And I invite our audiences to read this person was René Descartes. His book was Discourse on Method, no? And what is beautiful is that he started doubting everything but not just for the sake of doubting. He was trying to start what is true. And there was one thing that he cannot doubt about that. Okay, the one thing that he cannot doubt, it was that he was doubting. Ergo, he was thinking, ergo, he exists.
Yeah.
And he started building his philosophy over that cornerstone. No? And I want to emphasize him because after this the thought process, we are not going to go through the thought process in this video, but as I said, I encourage everybody to read the Discourse on Method. He started from that cornerstone. He tried to understand the world, and he came up to a conclusion that there must be a God that is infinite, all-powerful, and has not been created, has been there forever. And he just did it with his brain. I mean, thinking, using philosophy, no? So and that's beautiful, because if we follow that path, we came to a conclusion that there must be somebody that created all of the things, and that has been eternal and all powerful. We just don't know him. That person has to reveal to us, no? And that revelation of that God to us is what we call theology, no? So in the order of knowledge, what will make sense? What I think, or what an almighty, powerful God revealed to us? What will be more important? So we have right now a hierarchy of knowledge when you have theology, philosophy, logic and math, and then the natural science of or physics that comes, you know, and we have to have that order in thinking, that, and not the other way around, that, you know, you put physics here, or philosophy is just something that doesn't matter anymore, no?
So you have the hierarchy, but in a way you can also look at it as a ladder.
Yes.
What's the easiest thing for us to know?
Yeah.
The world around us.
Yes.
And so if you can then climb up from, you know, science or you know, physical sciences, natural philosophy, to look at the structure, get into the mathematics, and then see, well, this makes sense, so there's logic to it. So now what's the meaning of this? What's the purpose of it? When you get into philosophy, and then you think, well, there's so much order, there must be someone that ordered this, and you get into theology.
Yes, it's beautiful. I like the ladder analogy, really. And so, but you know, the world of the modern man doesn't see that, no? Actually, what we have right now is that you know, the science is that the rain's approach, and I will just put it on the quote, the science, because that's what I see right now. It's kind of two worldviews, no? The one is when we have true science as a method of inquiry and investigation of the natural world, and the other world that we have science as a belief system, no, as a religion. When, you know, in this category falls people that says, I don't believe in God, I believe in science, no. So you replace one God through another.
Yeah, well, and in that way, science can become, you know, like the ancient gods. This,
Exactly.
you know, the whim of the god of science says so,
Yeah.
and therefore this must be true.
Yeah.
Right.
Yeah. And when you do that, you stop thinking and you just start believing who whatever scientific is in the
On the latest papers, or you know,
yes,
the latest, you know,
or the
latest
famous
magazines.
scientific, no?
Yeah. I just got back into reading. I got a one of the latest editions of Scientific American from the library, and I want to get I used to have a subscription to that, and it's a great magazine. But it's you're looking at, you know, people talking about the latest research, and you know how things are being discovered. The problem with I think one of the problems with that we need to look at in this idea of you know, science as religion is that we have to acknowledge that the science today is gotten to a point where you can't just pick up a research paper and understand it. You know, the level of math, the level of, you know, the research, you know, the equipment that's used is far beyond the understanding of most people. And so in a way, so there has to be a level of trust.
Yes.
Of the scientists that are doing the research to say, okay, I trust that, you know, you understand what you're doing, that you understand the equipment you're using, that you understand the math, that there's a level of understanding there. But there can still be a place for us to say, well, does that make sense?
Yes.
does it make sense what you're explaining? And let's still we can all still think about it. Now we can't. I don't think we can question it to the level of I don't. Well, it goes back, as I say, it goes back to trust.
Mhm.
You look at, we've talked about before about people that believe that the Earth is flat,
Mhm.
and in one way you can kind of look at them and say, well, that's how can you believe that? We have 2,000 years plus
Mhm.
of science that shows that the world is round. But I think what that comes down to is, well, I just don't trust the scientists.
Yes.
And therefore, there must be some conspiracy for people to push this idea that the world is round and
And
not flat.
and I like that analogy because when you do that, you can always say, well, yeah, there's the evidence on 2,000 years more, or you can sit with that person, sit together, and okay, what can we see right now, and how can we demonstrate either way, which is the earth round or flat? What experiments can we run right now? Well, that you agree that it's experiment that we have all the variables under control and we are not relying on somebody else that can demonstrate. I think that will be a very different dialogue that's just labeling these people, oh, you are crazy, you or you are conspiracy theorists or something like that. No, that is the level that we want on science. No, and when somebody just when you ask a question and somebody say, oh, you don't understand, you wouldn't understand because of the science, it's so over you. I will say, if that person that has all the knowledge, all the studies, cannot explain you in analogies and in simple form why is this conclusion true, then you have a very good chance to start doubting about that person. No?
Yeah. So to close this episode, you have another great quote here from C.S. Lewis, and look, the intro to this quote, I like this: think and then do science. This, this, like we've talked about this whole episode, that it's important to not just accept facts, but to think through the process. In this other letter, this is also from Screw Tape Letters. So this other letter to this little demon. The little demon.
The big demon.
Yeah.
Teaching the little demon.
Thanks to processes which we set at work in them centuries ago, they find it all but impossible to believe in the unfamiliar while the familiar is before their eyes. Keep pressing home on him the ordinariness of things. Above all, do not attempt to use science, I mean real sciences, as a defense against Christianity. They will positively encourage him to think about realities he can't touch and see. There have been sad cases among the modern physicists. If he must dabble in science, keep him on economics and sociology. Don't let him get away from that invaluable, quote, real life. But the best of all is to let him read no science, but to give him a grand general idea that he knows it all, and that everything he happens to have picked up in casual talk and reading is, quote, the result of modern investigation. So, this when you do science, you see that the world is ordered. Like we've talked about this whole episode. You see that there is order in the world. And so a natural next step is to say, why? Why is there order? And as you said before, I want to do a series at some point on science fiction, because in looking at, and I think a big part of why I want to do a series on science fiction is this idea that there are things in the world that don't make sense yet. There are things that we don't understand. I think think about the, he says here, give him a general idea that he knows it all, and that everything he happens to have picked up in casual talk and reading is, quote, the results of modern investigation. The one last thing I want to mention about this, because I'm sure we'll talk about this more in depth at some point, at least I hope we do, is dark matter and dark energy. So in our investigation of the universe, there are things that are happening that we don't understand. We look at the rotational speed of the within a galaxy, and we say this doesn't make at the speed that the galaxy is rotating, and at the amount of mass that we can see, it shouldn't hold together.
Yep.
Therefore, there must be something that is adding a gravitational force within the galaxy to hold it all together. And that force is far beyond beyond the gravity of the mass that we can see. And so there's a theory that this is called dark matter. And it's called dark matter because it's dark. We don't see it. We can't measure anything with it. We can't interact with it. But now you have this in the world in general. You have people talking about, oh yeah, well, there's dark matter, as if dark matter is something that we understand.
Yes, that's true.
And it's called dark matter because we don't understand it.
Yeah.
Now, that doesn't mean we shouldn't continue to investigate it and do whatever we can to understand it. But this idea of something being in the general parlance of culture, that dark matter exists and dark energy exists, as if it's something that we already understand, and the science, the real science behind it, is important. But it's also important to understand that there are so many things that we don't understand.
And that's a good point, because I want to close this episode with that quote. Years ago, I did a little course from the University of Tokyo that was called "From the Big Bang to the Dark Energy." No, and in the end, the professor, who is a PhD in astrophysics, he recognized that between dark matter and dark energy, there's 85% of our universe that we don't understand. Meaning dark matter for 20% and dark energy for 65%. So there's 85% of our universe that we don't understand, and that's why they are called dark matter and dark energy. No, so just keep in mind when somebody thinks, "Yeah, we have all figured it out." We don't. There's so much more to do.
Well, and I want to go back to we talked about this before, that 100 years ago, we didn't think there's anything outside of our galaxy. We saw in the telescopes, we saw distant galaxies. And until about 100 years ago, we thought, well, the word we used for them was nebula.
Yeah.
We thought they were objects within our own galaxy. The size of our universe has grown exponentially as far as we understand. I mean, the size has always been the same.
Yeah.
But our understanding of the size of the universe has grown so much in the past 100 years. So how can we, if we've only known the size of at least the size of the observable universe within the last 100 years, how could we possibly got to the point where we understand it all?
Yeah.
Right?
That's true.
Well, so I hope this has been a good conversation starter, and I'm really excited to jump into this new series. And so the structure, the way we're going to be doing this series is we're going to be talking about, like we did with math, we're going to be going through the history of physics. We're going to be looking at physicists throughout history and the development of the discipline and the science of physics and then we're going to jump into a number of different concepts and theories in the area of physics. But so I hope that you continue to join us, and as we've said before, we want you to be part of this conversation.
Yes.
Yeah, so please leave your comments, any questions, thoughts in the comments below, and we read every one of them, and we'll do our best to bring them into our conversations.
Yes, please join us in this conversation. We are going to talk about a lot of interesting things in physics. I'm really excited about these new episodes.
Yeah, so join us again in 2 weeks for our next episode. And I want to remind you, if you go to thatnerdycatholic.com, you can sign up for our email list and get updates on what's going on in the Nerdy Catholic universe, and how we're exploring the world around us. If you go to thatnerdycatholic.com/merch, you can buy our t-shirts and other merchandise, cool Nerdy Catholic things to wear around. And if you go to thatnerdycatholic.com/support, you can support us, and we appreciate any financial support you can give. Even if you can't support us financially, we would really appreciate it if you would subscribe to our channel, like this video, and share it. But any financial support is greatly appreciated, and it will help us bring even more Nerdy Catholic content to you and to the world, and continue this conversation looking at science and looking at our place in the world, and just learning more and having fun along the way.
That's the idea.
Yeah. So thank you for joining us. We'll see you next time.
Thank you.
God bless.
System shut down.